Hey, Maddie. We are doing example 4 on 4-6. This is the back side. We've got a couple problems here, and these ones are going to be a little bit trickier than they were yesterday, and you'll see why here in just a second. We have this diagram right here going on, and we're talking about an airplane, which is up here, and it stays a constant 6 miles in the air, so that is not going to change. But we have a house right here, or a radar station or something, and as this plane gets closer and closer, we're talking about the distance that S is, right? So it's going to get shorter and shorter and shorter the closer overhead it is, okay? So like these distances right here are getting shorter the closer the plane gets to directly above us, okay? So we're going to read some information. We're going to fill out these 3 steps and see what we can come up with, all right? So an airplane is on a flight path that will take it directly over a radar tracking station. If the distance S is decreasing at a rate of 400 miles per hour. Okay, I don't even have an equation, but when it says S is decreasing at a rate of 400 miles per hour, what does that mean?
DS over TD.
Yeah, DS over DT is going to be our given. And I think possibly when it says decreasing at a rate, I think they're going to have us represent that as a negative 400. So that's kind of a tricky thing. Kind of like velocity as a derivative, like velocity is the first derivative. Velocity when you're decreasing or you're going toward the earth, velocity is negative, right? They'll represent velocity as a negative. So kind of along those same lines. When S is 10, so that's another given thing, S equals 10, what is the speed of the plane? Okay, so we don't know what the speed of the plane is, but let's look on this diagram over here.
Okay.
What is the speed of the plane? That's what we're trying to find. Okay, we have 2 variables basically going on here. We have an S and we have an X. So we know S is 10 and we know ds dt is whatever that was, 400, negative 400, okay? We want to look and see what will be represented by the speed of the plane. Okay?
No.
All right, follow me here. Ready?
I'm not.
Follow me here. X is the distance that we are away from like where it is, now, right? X is that distance. And if we're talking about the speed of the plane, that would be, in a sense, the rate at which this is changing, right? The rate of change of X,
Slope.
the rate at which that's changing. Don't think about slope, okay? The rate at which the X, the distance, is changing will tell us our velocity, right? It's like the speed of the horizontal distance. That will tell me my speed, right? The horizontal distance, the change, the dx dt, whatever it is, that will tell me my speed. Does that make sense? The dx dt would be that representation. Okay, so when it says we're trying to find the speed of the plane, that's like the displacement of our x horizontally. So finding dx dt, that was a little bit far-fetched because they didn't necessarily give that to you, but you have to kind of think, like what would be represented as speed in this case? And it's the displacement of that x or the dx with respect to time. Make sense, kind of ish? Do you see how that kind of fits together ish? Okay? All right, we have to think about what we're doing here. Like what is even going on? Well, like what equation are we doing? We're looking at this diagram and we have no equation yet. What? Yes, it's a right triangle. We can do the Pythagorean theorem. Yeah? Yeah, very nice. Okay, so Pythagorean theorem, a squared, b squared, c squared, and in this case, we have x squared plus 6 squared, and we can get away with just calling that 6 squared because that is staying a constant 6, like it's not changing. We don't have to represent that as a variable because it's not changing ever, right? That 6 is remaining 6 miles in the air as we're going along, right? The plane is not decreasing altitude, equals s squared, okay? So we're doing the Pythagorean theorem, which is kind of like the distance formula, I guess. And we have that equation going on here. I'm going to change this to be 36 instead of 6 squared. So if you want to do that also, doesn't matter. When we do the derivative, that 36 is going to drop off anyway, right?
0.
Okay, it's going to become 0. So is that our next step? Find the derivative?
2x.
Yeah, let's do that. Okay, so I'm going to do the derivative. I'm going to put it on here. 2x dx dt. Plus 0, really. I'm just going to say equals
2s ds dt.
2s ds dt. They are kind of confusing. Okay, and now we're going to plop stuff in. What are we trying to solve for?
I have no clue.
dx dt. Okay, we have s is 10, so I'm going to put 10 right here. ds dt is negative 400. Okay, but here's the problem. We do not have an x.
Well, shucks.
Well, shucks.
Take the derivative again.
We have to find what x is. Yeah, like we have our original function, and if we know what s is right now, we can plug s in here and solve for what x has to be at when s is 10, we can find what x is, right?
For like 100.
So x squared plus 36, because this is before we take the derivative, not after, right? Equals 10 squared, which is 100, right? We subtract the 36, so x squared equals 64, and x is 8. So when s is 10, we have found that x is 8. Now, they didn't give us that, but we had to go searching for it by using their formula again. And we can go searching for it, and now we have all of the pieces that we need, okay? So 2 times 8 times dx dt, that's my variable I'm solving for, equals 2 times 10 times negative 400. If we want to write that a little cleaner. And we got all the things. 2 times 10 is 20 times 400 is negative 8,000. Yeah, negative 8,000. And this is 16. And to get dx dt, we're going to divide by 16. So what is that?
500. Negative.
Negative 500. And what is that?
Feet. Speed, velocity,
is it feet?
Miles per hour.
Miles per hour. Why is it negative? And that's the speed of our plane, right? Negative 500 miles per hour. It's coming toward us, right? So it's not going away. It's not increasing in distance. It's decreasing in distance because it's coming toward us. Does that make sense? That's why it's negative. Yeah. Okay. Yeah, it is kind of weird. Okay, so this one was a touch harder in the fact that we did not have an equation to begin with, but we can see that it's a triangle, so we have the Pythagorean theorem, right? And we had to go hunting for some of the variables that we didn't know. Okay, so that one was just a touch harder. All right. Last one, we have accelerating objects, and this is kind of the same thing. We have a triangle thing going on here, so let's see what we've got. Find the rate of change in the distance between the camera shown in the figure and the base of the shuttle, okay? So, r, as this distance increases, so as the shuttle goes up, this distance is going to get larger and larger and larger and larger, right? Do you guys see that? As he goes up and up and up, that distance is going to get larger, okay? So, let's go through our equation, or our story problem, and let's figure out what we're given. Find the rate of change in the distance between the camera shown. The camera's down here, so if you want to put C here, this guy and the shuttle, okay? So, let's read that again. Find the rate of change in the distance between the camera and the shuttle, okay? That's the rate of change of that thing. Okay, they use r to represent that variable, but we're finding what? That guy's rate of change. What is his rate of change represented as?
T. No.
You're close.
R.
If this length is r, what's the rate of change of that? What variable do we use? dr/dt, right? The rate of change will be dr/dt. It's the rate at which r is changing with respect to time. That's dr/dt. Find dr/dt. That's what we are finding, okay? All right, and the base of the shuttle 10 seconds after liftoff. Ooh, 10 seconds after liftoff. What does that tell us? Time is 10, which is kind of weird because they tell us S is represented as 50 t squared, right? S is represented as 50 t squared. So in this instant, when t is 10, how big of a distance will this be?
I have absolutely no clue.
Yes, you do.
When t equals 55.
Huh?
You're plugging 10 in here, darling.
Why would I do that?
Because that's the formula and I tell you what t is. That's
25
basic
and 2
math.
zeros.
No, 5 with, this is 100, right? 5 with 3 zeros. 1, 2, 3. So S is 5, whatever, 1,000 feet in the air, something like that. Are we in feet?
Where did the T squared go?
We plugged 10 in for T, child. Right? They tell us T is 10.
I don't
We're
know.
finding the distance. Okay. Now, I want you to also leave S equals 50T squared there
No.
because, just wait a second,
Oh.
because we're going to use it here in a second.
A squared
It is
plus
not
B
staying a
squared.
constant 5,000 feet in the air, right? That is
No.
changing. So we're going to look at that here in a second. All right, let's see what we've got going on here. Assume that the camera and the base of the shuttle are level with each other when time equals 0. So they're saying this is directly straight across from the base of the shuttle and that distance is 2,000. Whatever. Okay? Good? All right, what's some other things that we know for sure?
2,000 feet in the air.
We're at 2,000 is the distance from here to here.
Oh, whatever.
2,000 is this distance. 5,000 is this distance.
Law of science.
We can do the Pythagorean theorem, kind of like what we did before, right? To find that. So 2,000 squared plus 5,000 squared equals r squared, and we can figure out what r is. 2,000 squared is 4 with 6 zeros. 5,000 squared is 25 with 6 zeros,
We did the first one.
which is 29 with 6 zeros. And we take the square root of that. So 29 million. 5,385. Just do 1 decimal. 0.2 equals r. That's what r is. Okay? 5,385.2. So that's what we know r is. 5385.2. Whatever that is. Okay? We have no equation yet. What's our equation going to be?
A squared, B squared, C squared.
A squared, B squared, C squared. So,
No.
all right. What's A squared?
10.
2,000 squared, right? Plus, are we going to use 5,000 squared or are we going to use S? Yes. So, in our equation, 2,000 is staying the same. That distance between the camera and the base of the shuttle is going to stay. But S, as the shuttle moves up, is not going to stay 5,000. So that's why we have to write it as an S variable
Why?
rather than plugging 5,000 in. Yes, ma'am.
Why don't we put 50T squared? Because that's what S is.
50 squared squared?
Just wait. Just wait. We will eventually plug stuff in. But to make it less complicated, it might be better to leave it as S squared before we take the derivative. I mean, it's, yeah. Equals what?
I don't know. R.
R
Oh,
squared.
we found R! So why can't we put that in?
Just wait, because the R is going to change, right? As the shuttle goes up, the R is going to change distances, right? This is going to change, and the S is going to change, right? The only thing that doesn't change is this 2,000. That camera stays 2,000 away from the shuttle at all times, right? That horizontal distance stays the same, okay? That's the only thing that doesn't change. So this is going to be our variables. 2,000 can get plugged in, right? And we don't care that he's 4,000 whatever. He's going to end up being 0 when we find his derivative, so I'm going to do that down here. 0 plus, there is one thing that we're still missing, but we'll get to that, okay?
2
S squared is 2s
ds dt
ds dt equals
2r
2r
dr dt.
dr dt. Now we're trying to solve for dr dt, so I'm going to circle him because that's what we don't know, okay? We do know r, that's this guy, right? We do know s, that's this guy, but we don't know ds dt.
Oh my gosh, can we find it?
Can we find it?
I don't know.
How do we
Probably.
find ds dt?
The same way we found the R in the last one.
Not quite.
Okay.
That was just plugging stuff in.
Yeah, why can't we
You
find
take the derivative of something.
You take the derivative. The derivative of what?
S.
Yeah. What's
What?
s? That's the reason why I had you write it like this,
Oh, 102.
right? 100t. Do we need dt dt? Because it's with respect to time, right? So we don't need dt dt, right? The derivative of 50t squared is 100t. Do you see how that works? I wrote it like that because yes, we're finding at 500 or 5,000 feet, but S is changing, so we have to write it also as 50t squared, so that ds dt can be written as 100t. So this guy is 100t. I'm running out of room. 100t. Okay? Yeah? Are we confused?
Yes.
Superly? Kinda,
So you
maybe.
put them all together right there.
2, S is 5,000.
Wait, what?
ds dt is 100t equals 2 times R is that the yucky stuff. And then we have dr dt. Okay? One more thing that we have to plug in actually. T is 10. Okay? And then we are done plugging things in. Oh heavens.
So
All right.
we could have just plugged in 5,000 instead of making 100. Wait,
What do you mean?
just kidding. I was confused.
Oh yeah.
But,
Yeah, because it won't be 5,000. It'll be 1,000. 1,000. So this guy ends up being 10,000 times 1,000 is 1 with 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 zeros, right? Did I do that math right? You can use a calculator if you want to. I don't care. Equals 2 times that number, whatever that is.
I don't know.
10,770.3.
10,770.3 DRDT. Last thing. Divide by 10,770.3. Yep.
928.5.
Okay, that's
I hate
DRDT. Okay, we're going to interpret that number. 928.5. What the heck does that mean?
I don't know, miles per hour, feet per second.
Is it my I think it's feet per second. But what does that mean?
That or
That this distance is increasing, you know,
By
like we
that-
said that distance is going by that many feet per second, right? So that distance is going to be larger and larger and larger by that at that many feet per second, right? Woo, what a mess. Okay? Good?
No.
All right.
Yeah. Can I
Okay.
summon you?
All right, I'm going to say goodbye to Maddie.
Bye,
Bye, Maddie.
Bye, Maddie.